All right, so what we can do is we can also increase the features which you feed to the network, but in this case we're not going to do that. We're going to see the impact of increasing the neurons. So let's go ahead and try with 4 neurons and see how it performs. So let's go and start it. Now you see that it's trying, and now you see that the training loss and test loss are both proportionally reducing. So we have gone through about 200 iterations and the loss is about 0.026. That's pretty good so far. So that's pretty good actually. So that's basically 99.98. So it has actually formed a circle in between. That's pretty good. If you see, the weights are pretty heavy here. It's negative 5.6. This is a positive 3.5. So this will kind of lead to overfitting. So what we're going to do is we're going to introduce the L2 regularization. We're going to start with the 0.01. And what's going to happen is that the weights are going to be less. They're not going to be as heavy as the previous time. Let's try this now. So you see here that the test loss is proportionally reducing as the training loss. So the weights are much smaller this time, and it has come to 0.092. It's trying further to go down, and there you go. So actually we can stop here, and you can understand that the weights are much less. So obviously, if you increase the regularization rate too high, then the whole neural network may fail to solve the problem altogether. And now if you actually come here and take a look at it, which we have not discussed earlier, is the bias. So each neuron carries its own bias. So here the neuron is carrying a bias of a positive 3.3. Here the neuron is carrying a bias of a negative 2.8. And here it is a negative 3.6. Here it is a negative 3.3. So now you get the big picture here. So weights into the input plus the bias is your output. So this is how your output looks like in each of the neurons. All right, now let's try another data set. So this one is a bit tricky. You see a spiral here, and we have 2 different kind of spirals. One is yellow, one is blue. Let's see how this neural network performs. So we're going to start it with the regularization of 0 to start with, and then we will see if we want to introduce it. We're going to freeze at 0.1, the learning rate. The activation function is going to be sigmoid. Let's start it now. So there you go. The output is reducing. It's taking a bit of time, and you see that it's actually struggling to achieve some kind of significant progress, as you can see in the output. So this is not really working out well. So I'm going to pause it, and let's try to use ReLU and see if that helps. So I'm going to start the iteration, and you see that the struggle continues, and there's no significant improvement even after 150 iterations.